welcome to this explainer. Today, we're diving into something we talk about all the time but rarely actually understand: the mathematical evolution of how we measure human intelligence. It's a fascinating origin story filled with ingenious breakthroughs, a lot of trial and error, and some surprisingly elegant math. I mean, think about it for a second. We throw around phrases like high IQ in everyday conversation all the time, right? But do you actually know the math and the history behind how it's calculated? Because honestly, it's not just some random number. At its core, the intelligence quotient is this brilliant mathematical solution to a really old, really practical problem.
So here's our roadmap for today. First, we'll look at the birth of intelligence testing. Then, mental versus chronological age, followed by the limitations of early tests, and finally, the birth of IQ.
All right, let's jump right into part one: the birth of intelligence testing. So while plenty of earlier scientists tried to, measure the human mind, the real breakthrough actually happened in France. Back in 1904, the French government issued this major mandate. They brought in psychologist Alfred Binet and physician Theodore Simon, and they gave them a super specific, practical goal: find a way to scientifically identify students who were falling behind in school. They weren't trying to map the human soul or anything crazy. They literally just needed to figure out who needed extra help.
And what's wild is how fast this all happened. In 1905, Binet and Simon rolled out a simple 30-question scale. Just 3 years later, in 1908, they made a massive leap. They started grouping questions by age for kids between 3 and 13. Basically, they figured out what a typical 3-year-old should be able to do versus, say, a 7-year-old. Then, by 1911, they tweaked it again, stripping out questions that relied too heavily on a child's environment or social class. They really wanted to zero in on raw intelligence.
Which brings us to part two: mental versus chronological age. Now, Binet ran into a pretty big hurdle. How do you actually quantify these test results across a bunch of growing kids? Well, he realized that a child's mental development doesn't always perfectly match the calendar. So he introduced this concept called mental age, or MA for short. Simply put, this is a metric based entirely on the age level of the questions a child can successfully answer, completely regardless of their actual biological age.
But to actually make sense of that mental age, you have to compare it to their chronological age, or CA. This is just the actual biological age of the child measured in years, basically how many birthdays they've celebrated. This distinction right here, between the mind's age and the body's age, was the absolute core foundation of Binet's whole system.
Okay, let's put this into perspective. Imagine a 5-year-old child. Their chronological age is 5, obviously. Now, if they take the test and answer the 5-year-old level questions perfectly, their mental age is also 5. MA equals CA. That's considered perfectly average. But let's say they struggle and can only answer up to the 4-year-old level. Their mental age is 4, which is below average. On the flip side, if they absolutely breeze through the 6-year-old questions, their mental age is higher than their chronological age. Above average! It was just a wonderfully simple, practical way to categorize students. Moving on to part 3, limitations of early tests. Now, I want you to really think about this for a second. If simply comparing mental age to chronological age tells us whether a kid is ahead or behind, why was Binet's test ultimately considered flawed? Like, what was the missing piece of the puzzle here? Well, the fundamental limitation was that, despite his genuinely brilliant invention, Binet completely failed to express intelligence as a single, unified numerical score. Sure, he could tell you if a child was ahead or behind, but he couldn't hand you a definitive, standalone number to represent their intellect. Basically, Binet made the mistake of equating mental age with intelligence itself. But think about the paradox there. A child's mental age is naturally going to keep going up as they grow, right? However, their underlying baseline intelligence relative to their peers usually stays pretty stable throughout their life. By only looking at mental age, Binet's system lacked a quotient, a stable mathematical ratio that could track your intelligence consistently over your entire lifetime, completely independent of the fact that you're just getting older. And that leads us perfectly into our final section: the birth of IQ. To get past that roadblock, the evolution of this metric required a few more brilliant minds to step in. A psychologist named William Stern was actually the first to hint at using a mathematical quotient. But the real game changer didn't happen until 1916 at Stanford University. That's when Professor Terman and his assistant Merrill took Binet's work and refined it into the famous Stanford revision.
This was huge because it established the very first universally accepted method to calculate the intelligence quotient, or IQ as we know it today. So, let's walk through the actual elegant logic of this calculation step by step. Step 1, you determine the child's mental age from the test. Step 2, you divide that mental age by their chronological age. That creates your ratio. And step 3, because dividing usually leaves you with these clunky, awkward decimals, you just multiply that quotient by 100 to get a nice, clean, whole number.
And there it is. That gives us the famous equation. IQ equals mental age divided by chronological age times 100. Let's apply this right back to our 5-year-old from earlier. A mental age of 5 divided by a chronological age of 5 is 1. Multiply that by 100 and you get 100. So an IQ of 100 is perfectly average. Now, if that same 5-year-old has a mental age of 6, well, 6 divided by 5 is 1.2. Multiply that by 100 and bam, their IQ is 120, above average. It's just an incredibly stable, beautiful piece of math.
So, we've traced how the messy, complicated reality of human intelligence was quantified, refined, and ultimately distilled down into a single, elegant equation. Honestly, it's an incredible historical triumph of both psychology and math. But I want to leave you with this final thought. While this formula brilliantly measures a very specific type of cognitive development, does this math truly capture the full spectrum of the human mind? It's a massive question, and it's one psychologists are literally still debating today. Thank you so much for joining me on this explainer. Keep asking those big questions, and we'll catch you next time.